Here we want to find a formula for the inverse of the function. Y is equal to e to the x over 1 plus 2e to the x. So we already know that y is involved in the function. So the next thing we want to do is we're going to replace and interchange x and y. So this is going to become x, which is equal to e to the y over 1 plus 2e to the y. So again, we're going to solve for y in the next step. So I'm just going to interchange or just rewrite this statement on the left side. And set that equal to x. And then solve for y. So what we're going to have to do is we're going to have to multiply both sides of the equation by the denominator, which is 1 plus 2e to the y. And the same thing on this side, 1 plus 2e to the y. And so therefore what that does is that eliminates the denominator here. So we have e to the y, and then that's going to equal x times 1 plus 2e to the y. Okay, now our goal is to get all the y's on one side. So in order to do that, we're going to distribute the x. So we have e to the y, which is equal to x plus 2xe to the y. And now we want to get all the y's on the left side of the equation. So we're going to subtract the 2xe to the y. So we have e to the y minus 2xe to the y, which is equal to x. And then what that's going to allow us to do is it's going to allow us to factor out because they both have e to the y in common. So we have e to the y, and what's left is 1 minus 2x, which is equal to x. And now we're going to divide both sides by 1 minus 2x. So we have e to the y, which is equal to x over 1 minus 2x. So in order to isolate y, we're going to use the property of logarithms. So we're going to take the natural log on both sides. So we have the natural log of e to the y, which is equal to the natural log of x over 1 minus 2x. And so since the base here is e, then now we have y, which is equal to the natural log of x over 1 minus 2x. And so now we can write this as an inverse function. So f inverse of x is going to equal the natural log of x divided by 1 minus 2x.